Welcome everyone to the Unboxing Careers podcast, where we shed light on what different careers are really like so that you can choose a career you'll really love. Today we are diving back into the engineering field with Laura Smith-Velazquez. But before we do, let's talk briefly about unboxing thoughtful gifts. At thoughtfulcollection.com, you can shop from a wide selection of curated products you can feel good about, helping you express friendship, gratitude, and love. The next time you need to, don't just gift, give thoughtfully at thoughtfulcollection.com. All right, I'd like to welcome to the show Laura Smith-Velazquez. She is an aerospace engineer. So Laura, welcome to the podcast. Thanks for taking the time to be here.
Thank you very much.
So we've had some mechanical engineers on, not an aerospace engineer. So let's kind of start with this. What the heck does an aerospace engineer actually do?
So the amusing thing is I'm actually a human factors and systems engineer and a cognitive scientist who works in the aerospace industry. So a lot of times we get called many different things. Aerospace engineering is one, but we also are often called systems engineers, cognitive systems engineers, experimental psychologists, and engineering psychologists. So I think that's the first thing to highlight, is that this career field has many different names. So it can be a little confusing.
I'm not going to remember all those. I'm just going to go with aerospace engineer, and you can correct me from there.
Is to understand human factors. So essentially what I do is I take the limitations and characteristics of people, and I apply them to the design of products in the aerospace industry, so that I make things safer, more reliable, efficient, easier to use, and actually more fun to use. So I do a lot of operator interface design.
Okay, so let's do it, if you can, kind of this could be stripped down to the very basics if you want, but let's break this down for like a layman, myself talking here. But like, what types of projects, based on your description, would you typically work on? Like, can you give us an example of what that might look like in real life?
Oh, absolutely. So I'm the one that designs the flight deck. So if you have an airplane, I designed the cockpit, like literally the computer display unit, the displays, the autopilot. If you have a space station, I'm the one that's going to design the controls for the space station. A lot of other things. I even do satellite controls, a lot of different systems.
So what drew you to that side of engineering, like that concentration?
Oh, so that's a little bit of a story if you have some time.
I got all the time.
Okay, good.
I have an eyelash right now, so you do that, I'll clear out my eyelash.
All right, sounds great. So when I was young, I was really interested in Star Trek. I watched a lot of sci-fi with my grandmother and read like sci-fi books. And so my dream was always to design a spacecraft or a colony on another planet. When I was 8, my parents got me a telescope, and my heart was set as an explorer. And so I was like, okay, well, what do I do to become an astronaut? Well, you have to be an engineer and you have to be a pilot. I'm proud to say 2 out of 3 isn't bad, and I've been an astronaut candidate for the Mars One program. So that's really what got me into engineering. However, I didn't know what kind of engineering I really wanted to be. A lot of them are aerospace engineers. And I decided to do my undergraduate in aeronautical science, which is aircraft system and navigation sciences. And then I wanted to have some backup, because also when you're a professional pilot, a lot of times if you lose your medical, you lose your job. And so I did a minor in meteorology, and I did a minor in aviation safety accident investigation. And what I learned is through internships that I didn't want to be a line pilot. And most of the autopilots were highly automated, and you click a button, the plane turns. And we had so many problems with the design of the system, didn't take into account the person that was trying to use the system. And I was doing a lot of line training at the time in my internship with American Airlines. And I had finished my bachelor's degree, and I was all set to be a line pilot and work for the airline in flight safety. And then eventually I'd go and do my master's degree in engineering, when I discovered my love of human factors engineering. It's one of the most creative forms of engineering there are. There are times where I'm designing flight deck avionics, and it's like designing a painting because you have a focal point. It's a lot of cognition and perception, and all the information flows out from there, and it's very seamless. And so I decided to go back to school and do a dual master's in human factors and systems engineering at Embry-Riddle Aeronautical University.
So you knew from a very early age you wanted to do something with flight. Let's just say flight, if I can.
I love
generalize
airplanes.
that.
And spacecraft.
But did you think you were going to go into the airplane side versus a space? Did you think you were going to space and the airplanes kind of was your jumping point to get there?
So, because I wanted to be an astronaut, I was very early on focused in space, but also airplanes, because almost all astronauts, when I was young, I think about it, I was in the shuttle era, and, I'm in Gen X. So space was very
Gen
much...
X.
I know, I was like, woohoo! Space was very much a high focus. But if you weren't in the shuttle and you weren't in the military, then a lot of times you weren't an astronaut. Unfortunately, at that time, it wasn't open to women. Women weren't allowed to fly combat. So that's what got me into the civilian world when it comes to aviation and aerospace. My master's work, I did long duration space flight, and then my backup was actually automation design. And at that time, they really didn't have any new projects for designing spacecraft. So I ended up doing more avionics and navigation systems. And that actually got me into autonomy and developing cognitive architectures for artificial intelligence.
Excellent. So I'm going to dig into kind of your career path and the education path for people here. But before I get there, I have this conversation with friends and family all the time. You mentioned that you are a candidate for the Mars One mission. So I always say, I had this conversation about 2 weeks ago about astronauts in general. Is that the first time, there's a lot of trust built into people. The first one going to space, we don't really know what's up there. Sure, your calculations look legit. And putting on a spacesuit and then going out of the shuttle, being okay, they assume the spacesuit's going to work, but actually, there's a lot of inherent trust built in there, and I always find that fascinating. The first person to do something, you're the person I could talk to. Does that scare the living heck out of you? Be hey, you know what? I'm going to trust someone to send me to a place that humans have never gone before, and I'm going to trust that's okay. Can you walk us through the psychology of this a little bit?
Sure. Well, I think one thing that helps is I am an engineer. So anytime I look at a system, and especially I've worked as a system safety engineer as well. So I'm trained to literally pick apart a system. What is the actual problem and how to solve that problem? And so a lot of that helps with the trust because you really are understanding most of the systems that you're going into. So that helps as an engineer. I would say as a mission specialist, somebody who didn't have that background would be a little bit more okay, I trust you to know what you're doing in your job. And that's kind of one thing you work as a team in engineering. You trust that each other knows what they're doing. They're specialists, and they work together as a team to iron things out. And then there's also the trust but verify, right? NASA in particular is very safety cautious, almost too much in a way, where we limit ourselves. But there's a reason for that. We're sending people up there. And the other aspect is, as an explorer in that heart, somebody has to be first. So there's got to be a motivation and a reason, and then this drive to make a difference.
Excellent. I know you mentioned, hey, we work as a team. We all trust each other. How do you know that person's actually they don't know? They've never been there, right? So you're trusting someone to kind of trust their own kind of instinct and education there a little bit. So I find it fascinating. So kudos to you. If you get accepted, you got to come back on and talk to us before you go. So
thanks. I mean, I apply every time, and I usually get a call back from NASA. So I get to there, and it's funny. I was lucky to talk to Garrett Reisman, who was designing the crew module for SpaceX, and he said it took him 10 times to apply before he got accepted. So you just got to be tenacious and keep trying.
I'm pretty sure this podcast will tip you over the edge. So
okay,
you're good. Just stick it on that resume. Okay, let's circle back to that career path a little bit. So you've had a lot of education. You went to Embry-Riddle, you mentioned. Kind of your path wasn't, your direction wasn't entirely smooth. It wasn't, hey, I got this, I'm going to go here, A to B, right? And you kind of zigzag. I think like every career pretty much is. If you went back to do it again, like walk, say, a high school student who's kind of wanting to go into the same field you are, walk them kind of the guidance you would maybe give to them is like, hey, pick an engineering school first. Does the aeronautical side, like Embry-Riddle, does that lay a pretty good foundation? What would you do over, I guess, maybe the better, what I'm trying to ask in a really long.
What's kind of funny is I don't think I would do anything over that I did, believe it or not, because it worked out pretty well. I'm one of those few creatures that I do every single thing I went to school for. And, being a pilot and engineer and, having been an astronaut candidate, one of the biggest things I think that helped me the best is I went and found people in that field and I queried them and asked them what the day in the life of your job is. And that's why actually these podcasts are so important, right? It's hard to find that and make those connections and see what they really needed. And what is it like? The next thing, choosing a university. Now, it really does depend. For me, going to Embry-Riddle Aeronautical University was a big, huge step. They're known in aviation and aerospace. So that was definitely a leg up. I think the other thing is that they were flexible in curriculum. I'm actually one of the very first human factors engineers to graduate from a degree program that they created specifically for a new field that was entering engineering. You get a lot of cool. Yeah, you get a lot of fields where you're very stovepiped, right? Whereas here, I had a hand in creating my own curriculum. Now I think a lot of them end up being psychologists instead of engineers, which I really wanted to be an engineer. So I was very focused on engineering, and I could even do dual concentrations, and I could put things together in a package, because there are a lot of jobs out there where, it won't be scripted, right? You will have to diversify yourself and kind of figure out where you go. But for me, I think the biggest thing is I always just did neat things, and I wasn't too worried about having to do each step perfectly along the way. And what that ended up doing is giving me a very unique, diverse background to where no matter where I went, people are like, wow, you're impressive, So like when I finally got to that point, I was like, yay, okay. And how I did that really was interviewing people, being flexible, creating, a background, and not actually try to doing the step ladder stovepipe. The other thing is you can get degrees where if you're a physics major or a math major or, even a psychologist, right? There are actually psychologists who end up going into engineering. And the degrees are rather broad that they can be applied to specific fields. And so that's actually very helpful.
So if someone, say, reaches out to you and says, hey, Laura, I'm looking at going to school, this is what I want to do, what type of school should I be looking for? Like you've got to provide an advice, like for a track, right? Go to an engineering school, go to an aeronautical school. Like where would you advise? I know this will be case by case, but where would you generally advise someone to kind of like start?
Well, it actually depends on what they want to do. In my field, you can be either a researcher or a practitioner. A practitioner is somebody who applies to product design and development in engineering. And you have to know a little bit of both in human factors. Humans are non-deterministic systems. So there is so wide variety. So every time I sit down and design thing, I have to understand who I'm designing it for and how they do the work they do and what tools we have, and then apply it. So that is a little bit of researchy, because we do a lot of testing to verify our assumptions of how well a human does. So for human factors, I would definitely go to a school that allows you to do that kind of level of work and at least get a master's degree. So a school that has more of an advanced degree and where you can do a lot of internships and explore whether you want to go into the research side or product design and development side. The other aspect is if somebody wants to really, like, say they want to design a cell phone, then that's a little bit more user experience and software engineering. They're still called human factors engineers, but they're much more focused in that visual display design. But they still will need to understand cognition, sensation, perception, but they don't need all the physical ergonomics like biomechanics that you would have to if you're a human systems integrator doing like an entire aircraft, right? So in that aspect, they really want to focus on things like coding, right? A lot of web design, like Android, that kind of stuff. If you are doing more human systems integration, you're going to do a little bit more of what I do, is where you're going to come out and design an entire aircraft and all the different elements that go into that. You're going to want to focus on systems engineering and then get a good psychology base, because they really have to understand that cognition and how you use that and information structures and architectures. So it really just depends on what area in human factors engineering that you're going to go to, especially in aerospace. Aerospace can be very broad. For example, I do cognitive architectures because I'm also a cognitive scientist. So I have a lot of that psychology cognition background. And when you're doing AI machine learning, you really have to understand how the brain works to create a system in order to do that. So you're looking at neural nets. You're looking at Bayesian networks and probabilities. So there comes in more statistics. So it really just depends on where you're going to go into the field.
That's really cool. I love the answer. No, but I love the answer. I think there was a lot of detail in there that a lot of people would kind of glance over and go, well, it kind of depends here. So I think your advice was, I think it was perfect. It's perfect. So you mentioned before I hit you with that question that, hey, what does a typical week look like? Or what does a typical job actually look like here? So maybe can you break that down for what you were most recently doing with, I don't know, we could use designing an airplane for an example, but I'll let you kind of pick the project and just kind of walk us through what a typical scope might look like.
Yeah, so one of my favorite projects was doing a sonic boom display to enable commercial supersonic transport. And that was a NASA Armstrong program. And it's really hard to take an algorithm. This one was a wave propagation algorithm. So it literally mapped out how the sonic boom would travel through the atmosphere and where it would hit on the ground. And so I was actually taking that algorithm, incorporating it into a business jet architecture and making a flight management system so pilots could see where it would hit and could actually manage their boom to either avoid it from hitting the ground or they could place it in a particular spot. So how do you visualize something someone can't see? And so that was the very first thing I was like, oh, okay. And how does that interact with how you fly an airplane today? It's going to be completely different. It has completely different technology. So a day in the life is one of the first things I did is figured out, okay, well, how does this new system and technology differ from what we had today? So I went out and I talked to Concorde pilots back in the day. So I got 3 Concorde pilots who were advisors, and I asked them about the day in the life of their job. And then I learned about, okay, well, how did the technology change? So then I went out and I got some goal-directed task analysis from airline pilots and some of the stuff that Micah Ensley has done with John Hanseman at MIT. And I read through that. And then I went out and I talked to supersonic pilots at NASA, and I talked to corporate pilots at Collins Aerospace, where I was working at that time. So a day in the life is a lot of interviews. And then I took all the data together and how you would visualize. And I did a whole bunch of visual display design based on sensation, perception, synthetic vision of how a system is used in a flight deck to create the outside world inside. And then I created 2 or 3 different types of drawings. And then I went back to all these different pilot working groups, and I worked with them to understand the information and data requirements they would need to use such a system. So that's the systems engineering point, where I'm figuring out what are the tasks, what are they trying to do as a job, what is the technology I need to create, and how do I display it. So a lot of concept drawing, operational concepts, drawings of what they actually will see. And then the next step was to actually prototype them. So my software engineer that I work very closely with, we started creating different software functionality in a display system. And then I put it in NASA Langley Sim. So now I'm in the simulator testing all the things in the design that I created. And then I bring the pilots in and I actually run them through an operational concepts, and I see what errors do they make, how well does the system work, and I get their feedback. So human factors engineering is very hands-on. You have to like people. I will admit that. It's a lot of interviewing, figuring things out. I don't always understand the domain, so I have to work. Matter of fact, my husband's an aerodynamicist, so one of the first things I did is I sat down, and we were actually in Buffalo Wild Wings drawing on a napkin the sonic boom and how it goes down, and it was great because I got to use my meteorology minor, the atmosphere, and so we were talking about all the different stuff and how we would visualize it and what would be the best way to try and show contours of how a mountain might obscure the sound wave from getting over it, and how I would incorporate that into a visualization that pilots could actually use. So it was a lot of fun. You learn a lot of different information.
So the project sounds really cool from beginning to end of what you just described. How long is that?
So I did the first prototype within 2 to 3 months. And I would say the second quarter we had pilots in the simulator. So I did the first iteration of drawings, and then the second iteration was software. And then by the end of the year is when I did my first operational concept. And it's a very iterative process.
Okay. And is out of this, it sounds very intensive, right? There's probably a little bit of downtime when you're interviewing people and kind of doing notes and stuff, but are you laser focused, like let's just say that first quarter or the first couple months, you laser focused 40 hours, or do you have time where in this process where there's tasks that allow your brain to kind of decompress a little bit, right? It could be data input, it could be formulating stuff on Excel.
Yeah, very much so. So there, I wish human factors had good model-based systems engineering tools that we could use in a computer, but a lot of times I'm using like Photoshop or Illustrator or even PowerPoints to do drawings, and Figma, because you're doing collaboration, storyboarding, with users, especially if it's virtual nowadays. Thank goodness we can do that. It was a lot harder in the day, and I'd have to travel a lot of places. And then for the requirements management, I'm defining information requirements based on the goals and the tasks that they have, and that also defines what features and functionalities I need to design into the system, and that's very much a spreadsheet. So there's a little bit of both. One of my things that I really like is doing personas and journey mapping, because we had supersonic pilots and we had commercial pilots, but we didn't have supersonic commercial pilots. And the technology, so Concorde flew heat temperatures. Our technology today, we're so beyond that, you don't have to do that. So I had to figure out what the day in the life of this new pilot would be. And so that required, a lot of storyboarding and going through this journey map and creating a description of who they are and who it is I'm trying to design for and what knowledge and abilities they have to do their job.
That's pretty cool. How about, this could be a terrible question for you, but like a typical career path, and I don't want to say like from entry level to kind of retirement, but let's go those first couple of years. If you are coming out of college, you already start applying for jobs. Does it matter the type of job you're looking for kind of those first couple of years, or get any sort of engineering job that is in your realm, learn by doing, and then kind of navigate there? Where would you advise people to kind of plant their seed?
Is a little bit more on the career path they want to go into. In aerospace, doing design of airplanes, I started with Northrop Grumman right away because they were doing big systems. They had the first $2 billion contract doing advanced Hawkeye. It's still one of the largest glass cockpits in the world, and I got to design that system. So I was very strategic about the companies and the type of work I wanted to do. They also had a space program, so I was like, okay, I could go in and do that. And that was nice because then I got the whole gambit of being able to be a systems engineer as well as a human factors engineer, and put my two disciplines early on from a program that went from, we had to reverse engineer the aircraft because it was a 1960s aircraft and there were no design documents, to all the way to flight tests. So that gave me an opportunity. If somebody is wanting to do more user experience design, they're going to want to really get into more of a web development company, or, like Apple, right? Okay. Or if they want to design hardware technology, they might do something like Google Glass, or target a company that's going to do wearable computing. So I always say for new people who are engineers, explore, because your first job really is your first job, and you are going to get basic experiences, but try and explore the domain that you want to get experience in, because that will help you get your next job.
What is the level of competition for those people coming out? So is it a really competitive field, or is it kind of depend on your concentration?
So one of the blessings of human factors engineering is there are not enough of us, so we're always on demand. The other aspect is that you can cross domains very easy. So I could go in and work medical systems as opposed to aerospace. Matter of fact, I've even designed machine gun stocks. I went from doing aircraft to personnel equipment to even wrote some of the touchscreen display standards for SAE that people design to. So it's very broad. So the nice thing about that is that even in the areas that are competitive, we all know each other. Like in unmanned systems, we literally know each other. Even all the aerospace human factors engineers, there's only so many people who have those knowledge, skills, and abilities to put that package together. Same thing with all the AI. So it can be kind of competitive in that aspect, but there are so many jobs out and there's just not enough of us that it's actually a really great field to get into for that reason.
Awesome.
Lots of variety.
About the type of work you do, what do you like most about it?
The creativity. I said, it's one of the most creative forms of engineering. The other aspect is I get to help people. I'm literally getting into their brains of what they do, and they may not even know what technology needs they have, but I can solve that problem. I'm always learning. It's a field where, honestly, if you want to work on one box for 25 years, it's not a field for you. You're going to be working on many different things. There's a lot of variety, a lot of education and domain knowledge. So you're really like always curious and learning about things, and then coming up with such creative solutions to actually improve other people's lives. So it's very fulfilling.
Awesome. I'm going to flip the script on that one then. What do you like least about the type of work you do?
Oh, wow. The fact that a lot of times I'm the only one for the entire company. So when you get out of a job, a lot of times you are the expert, and there's not going to be a lot of mentoring because pretty much you are the only one. I've created a lot of process and procedures, and not everyone considers you a traditional form of engineer. So that is also, you're always having to prove that what you're saying is not opinion, that it's based on fact, and that you have all of this. So you really have to know your stuff. You have to be sharp, and you have to be confident and forward to make your point. And for me, so I've always been very confident and forward, but I don't know if you noticed, but I tell a lot of stories. I'm Cherokee, Chichalegi Anyoweya. We are storytellers, which is great when I'm creating all those journey mappings and stuff. But then I get in front of people and I said, no, this is not right. This is what we have to do. And I have to be very succinct. And, that's one of those engineering parts where I'm the great storyteller. Like, Laura, you have 5 minutes. Like, I can do this. Which is great. I had an impromptu speech about my whole life for once in 7 minutes. So I know I can do this.
There you go.
But those are the challenges, the things that I don't like as much, but they so outweigh everything else.
Very good. And how about essential skills in your field? So are there skills that you would say, okay, if you don't possess these, it might not be the best field for you?
You do need to be a bit of an extrovert and be able to work with many different kinds of people. because we're designing things for people, you're going to get many personalities. But the good thing is people love to talk about themselves. So usually you can break that segue. But if you're someone that just wants to data chunk, it's not going to be human factors. Usually we're a bit more extroverted. We're curious. We're 20 questions. So you have to learn to ask a lot of questions. Not lead a person, but be able to explore and discover. The other thing is a very traditional engineering skill. You don't have to have the right answers, but you do need to understand how to ask the right questions. So when you're looking at an engineering problem, being able to get down to the root thing that you're trying to design for or solve is critical. So that's where that curiosity comes from. And then being able to pick that apart into needs and pieces and requirements of what you need to create a solution for that person and design a system. Human factors engineers are very much systems engineers. They just focus on the operator, interaction with the hardware and the software. And being able to analyze a system and break it down into its component pieces and understand what the root of the problem is and how you're going to solve it, and then being able to verify all those assumptions and do this continuous loop is critical to our field.
Excellent. Let's go into advice for, say, high school kids. And I kind of do this on two different ways. So one, we might have someone who knows they want to go into this field or a very closely related one, right? And they'll figure out kind of that niche. And then there's others who say, hey, I think engineering might be for me. They have no idea what concentration. They don't even know they want to be an engineer. Any advice you might be able to offer those students to kind of figure out, one, whether it's a good fit for them, or two, they can figure that out later, but the things you advise them at that point will come in handy later, if that makes sense.
Yeah. So as a high school person, I would say you can actually go visit companies and find those human factors engineers. There are also some companies that provide high school internships. There's also organizations, like we have the Society of Women Engineers, we have Human Factors and Ergonomics Society. A lot of them do STEM programs and introduce you to careers. And those are really nice because you can try it out. Like I put a plug in other than HFES. I'm also a member of Civil Air Patrol, United States Air Force Auxiliary, and we have a huge aerospace education program. And so it's joining those organizations like, if you want to be an engineer, maybe you're interested in robotics, go try the robotics contests or programs, or if you're interested in rocket, it's really a career exploration. And that's one of the best ways to explore if something is really interesting and you like it. Like, I love physics. So for me, anything that had airplane parts or movement and I was going to do any experiment was great for me. But not everybody likes that kind of stuff. So just trying it out. One of the things I do also is I connect high school students up with companies to job shadow so that they get an idea of what a person does in that career. And that's really good because then they can actually go in and look at it and see if they like it. So outside of joining the organizations and the events like CAP and robotics and some of the I would say like the, at least for us, Society of Women Engineers, we have a really good, K through 12 program that we can give experiences to kids to see if they like it, or sometimes they're not as confident and they need to kind of build their confidence up. So there's a lot of good programs out there to do that. So that's what I would do as a high schooler. The other thing I would do is, I'm a big reader. So if you're a reader and you like reading about things, I would get, biographies of different engineers. You can see what Goddard did. And I really enjoyed reading about those. And being from a small town in Michigan, we didn't have a lot of resources. So there wasn't these big companies to go to. So that's mostly what I did, is I ended up reading and exploring about different careers in technology development. And, like I said, I went back to Star Trek and all these, Anne McCaffrey, Dragon Riders of Pern, where she has a colony on another planet, and that's where I kind of got I would really like to explore that and learn more about it, and then went from there.
That's phenomenal, but I'll try to put some links to the organizations you mentioned in
good.
the show notes and the website as well. So
I think that's the hardest
might be
part.
delayed, but I'll try to stick them out there for you. Yeah.
Yeah.
Would your advice change at all for students in college, or would it continue on for those same students?
So in college, I think it's more targeted. Internships are really important. I mentioned the fact that I thought, I'll be a line pilot and then I'll figure out what kind of engineering. And then I learned, through the internship that I would be a horrible line pilot. I would be so bored. I'd drive my co-pilot nuts talking his ear off because I talk a lot. And so that was a big thing for me. That career exploration was really interesting. And because I also had to make alternate choices too. I paid my own college. I supported myself through college. So there were certain limitations. And that was one way where I could do that career exploration inexpensively, to actually go and talk to people. But once again, I went into books. There's a really good book on information visualization perception for design. That talked about all the sensation, perception, and cognition. And that's how I kind of got into psychology. And then there's another book on anthropometry, which is the study of body size and measurement. You have to know that to develop helmet-mounted displays, or even your glasses, right? Or a control yoke. And so I started reading about that, and I went, wow, biomechanics is really cool. Like, what could I do that combines all this? Well, guess what? Human factors engineering. So
this is a lot easier now because people can just Google it, but how did you find those books, the right ones to read?
I asked people. I asked what's in your toolbox, and especially as a young engineer, even I was still exploring because you don't get everything in college. And when you're, the person that says, okay, you're the only one, you're the expert, you're like a deer in headlights. You're like, okay, no, I'm the only one. So networking was really important. Like I said, Human Factors and Ergonomics Society was really good about that. We have technical groups, so I joined technical groups. There's an aerospace technical group, and then I'm part of the HART technical group, which is human autonomy, robotics, and teaming. And I was able to connect to people and understand where I needed to go. So even though I didn't have even necessarily within my college, because it was a new degree program, or in my workplace, I was still able to go to these technical groups and societies and get advice and connections and ask my 20 questions.
It's awesome. How about in your field? What do you find to be the most challenging part of it?
The amount of information you have to learn. You really have to be someone who can learn quick. I designed such a broad breadth of systems, from, like I said, the satellites to the machine gun stock to your helmet-mounted display to your cockpit. I've even redesigned seats. Having the time in your job to actually, I call it digging in like a tick, while you're being pulled so many different directions. And I'm not a coder per se. I can code, but you don't want my code. I'll just put it that way.
You know enough to be dangerous.
Yes.
And that's about it.
Human factors, I'm very deep, but in systems, I'm broad. So one of the things I do is I will sit down with a lot of the other engineers I work with, and I will dig deep, because almost every system interacts with a human. So I really have to understand. And if I don't, I need to be able to sit down with someone and figure it out. So that can be very challenging, as much as it's variety and having that ability to learn and to continuously do that while you're trying to design something too.
So this question just occurred to me. How do you factor in left-handed people when you're doing designs?
Oh,
Because obviously, I mean, it's a smaller population percentage, right? But
Mhm.
I don't know, maybe people in aeronautics, like they've got to be ambidextrous, but like, how do you factor that in?
So there are actually accommodations that you can make to where you have controls on both sides. Or instead of putting on one side or another, you do a central layout. A control yoke I've designed for either side, even though when you're flying, you almost always fly left-handed, but you might switch seats, right? So a lot of that is just considering the task and who is doing it and trying to make things so that you're not using, I guess a good example would be color blindness. You can design systems so anyone can use them, even if they're colorblind. You don't code with color. You do textures and contrasts, anything as, color. You don't want to use colors too close together. You use big contrasts. There are different ways to code information to be more inclusive in the population in general. But that's the real critical thing, is to ask that question. Do you need to? Who is going to actually use that system?
Yeah, that's cool. I guess it makes sense when you talk about like flying with the left hand, because I think about driving, right? I'm right-handed, but I've always got my left hand on the wheel, right?
Yep.
That makes sense.
Yeah. And I am ambidextrous, by the way, so I think that's interesting.
Just showing off on us now. Here we go.
It's funny because I use a right-handed mouse with my left hands, and I don't change the buttons. And when I get tired, I just put it into my right hand without thinking about it. So there's a lot of those psychomotor skills and training that you can train.
I've got to believe that's got to be really cool, though, to figure that out. So
it is. It's fun.
So the training part is interesting. So I'm right-handed. When we initially went into lockdown during COVID, like I'm outside on the driveway with my little kids, and I'm like, well, this is boring, right? And I taught myself how to throw with my left hand. I'm just bouncing a ball off the brick wall above the garage. Yep. I'm still not good at it, but every now and then I'll go out there and I can still hit a spot with it. I'm like, but that first, 3 days, the ball's going everywhere, right? I'm hitting the car window and stuff. It's pretty cool, though. You can see your mind pick up on the motor skills on it. I think it's cool.
Yep, you have to retrain yourself.
Yeah. Laura, how about the most rewarding part of your career?
I think it really is working with people, especially when it comes to safety. It's a real great feeling when someone says, yeah, this is so much better. And you know that you got it. It's a lot of work to get there. And it's not just one person. I keep telling people, you ask 10 pilots, they'll give you 10 different answers. So it's a real challenge to design for a very wide variety of people. When you've made something safer, or when you've made something much more sustainable, like the big thing with supersonics for me was when I got our team got the algorithm down to where we can do a calculation coast to coast in 10 seconds, all the way through our flight, so they could use it real time. And they were like, oh, I wish I had this now. I was just like, yay. It's such a wonderful feeling to be able to help people and see the impact.
That's awesome. How about, before we wrap up here, how about any common misconceptions about your field?
Oh, wow. That any software engineer can do it. I get that a lot.
Take that, software engineers.
Yeah, it's like they don't understand how the brain works or perception or any of that. And just like I can't code just anything or create this really cool back-end architecture to enable my features and functionalities, but it will work with them to make sure they do. That's always kind of a common misconception. The other thing is, a lot of times we're not always treated as regular engineers, so that's something that until we had systems for artificial intelligence, I don't think people understood how difficult it is to design for non-deterministic systems that have a high variability. And suddenly, when I started working in the autonomy field, people went, I got what you've always been trying to tell me.
That's interesting.
This is exactly, it's not easy because in most engineers, you can do, well, I'll give you an example. With my husband being an aerodynamicist, he can design a wing and he's got surface area. It's always the same equation. No matter what wing he's designing, no matter what he's designing for, it's the same equation. In human factors engineer, I have to go back to first principles every single time and create that equation for every design that I do. And until engineers got to artificial intelligence, a lot of them in the other fields they had their equation that somebody figured out in physics a long time ago, and they didn't have to do that every single time they designed something. So when we finally started doing more technical artificial intelligence, creating neural networks, and figuring how to do reinforcement learning. And these are all cognition principles that we tried to map into computer science. They didn't really understand exactly what it is that I was doing and how I needed to do it and how technical it was, that it's not an opinion. There's tons of research and studies, and then I have to apply it. So that was like, actually really satisfying.
Awesome.
Finally.
So do you look at your husband's work and be like, software engineer could do that? Same formula.
Runs the autonomy lab.
Yeah.
But no, we're just different disciplines, and we have our trials and tribulations, different challenges. And I still love aerodynamics, though.
Fair enough. Laura, what did I forget to ask you that you feel is important for the audience to know today?
Oh, wow.
If anything.
No, I think you're really thorough. I think one of the biggest things is to ensure, because there's a lot of stereotypes in engineering. Human factors engineering, I don't do a lot of math. Mostly I do trig. I have to understand the principles of calculus and how to apply it, but I personally don't do a lot. And if I do need to go down and sit down and do a lot of equations and math and stuff, I pull out a book and I refresh myself, and then I go apply it. Okay. So there's a lot of stereotypes. Like I said, a lot of what we do is very creative and very broad. So you're definitely not going to, be the subject matter expert working on a box. I think breaking down those stereotypes for engineering is really important because people don't see themselves in these fields, and every different discipline in engineering is different, so the stereotypes don't fit often, and we need to communicate that more and get that out so people aren't afraid to even try engineering.
Well said. Well said. All right, Laura, I'm going to take you out of what you're doing. Can't be related. I'm going to ask you to choose a different career that you think you would be happy doing. What do you think you would choose and why?
Oh, my goodness. That's hard because I love what I do. Let's see. What would I do and why? Because I'm doing exactly what I love to do and why. All right. Oh, I got a good one. I kind of do it in my downtime.
Okay.
As in Civil Air Patrol, I do a lot of emergency response.
Okay.
So, search and rescue and emergency response. And I think I would love to do more of like the incident commander. You actually would use a lot of the same skills in engineering to respond. I was going to
say, you're probably looking at a problem, diagnosing it, figuring out solutions for it. Yeah.
To be an air branch director, work in incident command and emergency response. I always tell everybody, if I didn't work for a living, I probably would be doing Civil Air Patrol for a living because I love the aerospace education, and we do 90% of the inland search and rescue for the U.S. But I would even get into it more as a career, and I'd probably do training for other people who, really want to learn how to be incident commanders. And isn't it funny? That's kind of very way over here, but it's working with people, it's safety, it's impact. So it's all those same goals that I would love to do.
We get a fair amount of people going gardening. All right. So
I'm a master gardener.
Yeah. So,
Yep, I
it's
am a
peaceful.
master gardener. That's very true.
Well, Laura, this was a pleasure. If someone wants to reach out, ask you a question about the career, network with you, whatever, is there a good way or preferred way someone can get a hold of you?
So I am on LinkedIn. It's probably the easiest. You can give them my email. I'm happy to do that. I mentor a lot. So either through the Human Factors Ergonomics Society or Society of Women Engineers. In both organizations, I do a lot of mentoring too. So, like happy with my email or whatever way.
All right, we'll throw a link in the show description for your LinkedIn. If you want to give me your
it's probably
email,
the easiest.
Okay. If you want to give me the email, feel free to just let me know separately, and we'll hash it. Probably just link it on the website versus pasting
Giving
it where it's going to get
world
scraped.
at large.
Yeah. So check out the website. Shameless plug. Check out our website. See if the email's up there. Otherwise, LinkedIn's the best way to go.
Yeah.
All right. So normally I do the close and I read it for you. I'm going to ask you to piggyback with me here. So Laura Smith-Velazquez, everyone, I would normally say aerospace engineer here. Give me the rundown.
Laura Smith-Velazquez, Gawanisco iyo Daleha, Human Factors and Systems Engineer and Cognitive Scientist.
There you go. Hope everyone enjoyed the episode today. Be sure to like, rate, review, and share it share the podcast with others if you can. If you want to explore other careers or to share yours with us, please check out our website for more. Until next time, be kind to one another. Go Bills. Unboxing careers.